Today we're gonna work on the question Reconstruct Itinerary. It's a hard question, and the question states you are given a list of airline tickets, where tickets I equals from 2 represent the departure and the arrival airports of one flight. Reconstruct the itinerary in order and return it. All of the tickets belong to a man who departs from JFK, thus the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. So for example, the itinerary JFK LGA has a smaller order than JFK LGB. This is because A comes before B. And you may assume all tickets from at least one valid itinerary, and you must use all the tickets once and only once. So this question, immediately we can think about the Eulerian path. If you don't know what a Eulerian path is, it's basically saying we can visit these vertices multiple times, but we can visit its edges, like these directional edges, exactly only once, and we have to visit all the edges, and we can only visit them once. So let's look at example 1. Basically example 1, it's really simple. We don't have to worry about the order because there's only one outgoing bound like direction for each of the vertex. So basically there's just one solution if we start from JFK, right? So it would be JFK, MUC, LHR, SFO, then SJC, which is the output. And let's look at question 2. Example 2. Example 2, this is the graph. And then if we have to start with JFK, like this question states, we always begin with JFK. Then there's two outgoing directions, right? There's two ATL and SFO, but because A comes before S, JFK will go to ATL first. And then from ATL, we also have two directions. It has the option to go back to JFK or go to SFO, but because J is before S, we're gonna go back to JFK. Now that we're back in JFK, we've already exhausted this path, so we only have one other path, which is to go to SFO, right? Then after we go to SFO, SFO only has one outgoing path, which is to ATL, right? So SFO goes to ATL, and at this point in ATL, we already used this JFK path, so we can only go to SFO. So then the last one would be SFO. So that would be the smallest lexical order for example 2, which is correct. So let's start writing our code. I'm gonna, for my adjacency list, using from collections, import default dictionary. And then first, let's start writing our adjacency list. So our adjacency list will be a default dictionary of lists, and then let's parse the data that's passed in. So the data tickets is what's passed in. It's a list of lists, and it has like MC to LHR, so this is the source and this is the destination. So I can do something like for source, destination, and tickets, and then adjacency list, source dot append destination. So this is where we span our adjacency list, and after that's done, we want to do it in alphabetical order. So what that means is we can do something like for destination in adjacency list dot values. So we're only sorting its values. Every node's value is in here, right? It's the key is the source and the values are the values. The destination is the values. So we want to sort the destination. In this case, we can just simply do destination.sort, and it would sort this in place. then our adjacency list has all its destinations sorted in alphabetical order. That's when we can start doing our DFS. So to solve this, we'll do a DFS that takes in a node, and then I would say, well, adjacency list node has outgoing bounds, right? So when this is not empty, it means it still has outgoing bounds. Arrows pointing to some other vertices, so we have to we'll recursively visit them. So DFS adjacency list node dot pop 0. So since it's already in order, we can pop the first one, which is the smallest alphabetical order, and then we'll keep doing that until we exhausted all of our edges, like outgoing edges. And once we've exhausted everything, let me create a result list. We can append it to our result.append node, and then after basically we just return the reversed result. Oh, I haven't passed in, so basically I need to pass in DFS JFK. Let me explain the result a little bit. So why do we have to return the reverse result? So basically, let's look at example 2. If example 2 is the one given to us, then the first one that's passed in would be JFK, right? And then when JFK is passed in here, in our adjacency list, JFK points to ATL and SFO, but obviously ATL would come first, so ATL is popped here, and then ATL comes into our depth first search, and then it enters this while loop because ATL has also two outgoing bounds, one to JFK, one to SFO, and then here it would pop the JFK, right? It would go back to JFK because JFK comes first alphabetically, and then keep in mind that this is recursion. We don't append the results yet because we haven't exhausted all of our outgoing path edges, so it would keep going, and as soon as we exhaust everything and we reach a node where there's no more outgoing edge, then it would start to append to results. But at this point, when it appends, it would be appended backwards. So basically, looking at our output here, this output is actually from example 1, but right now it's like outputting JFK, which is everything JFK MUC, this one in order, but actually here when it appends to the result, it will be backwards, like SJC, and then it backtracks to SFO, and then backtracks to LHR, etc. That's why we're reversing our result. Please let me know if you have any questions, and thank you so much for watching.